Hi everyone, I am Lucas Vasconcelos and I work with Dr. Roger Hill in this class as a teaching assistant. I recorded this short video to introduce you to the Roborobo Kit Level 1 and to the Logic software for robot programming. I hope you enjoy it. Roborobo kits are manufactured in South Korea and they were originally created to be used in science education contexts. These kits enable learners to assemble and program different types of robots. For example, the RaceBot and the RabbitBot. These are types of robots that you will be able to build with the Level 1 kit, and each of these come with different functions. In the robotics kit, you will find many different parts. The first one of them is a CPU board, which acts as the brains of the robot because it stores the programs you create for your robot. It has 8 kilobytes of memory, and it contains letters and numbers that identify the holes around the edges. It also contains holes for the CPU, as well as the input, output, and power circuitry. The DC motor on the robot operates on a direct current, and it is the main part for turning the wheels and making the robot move. If you program the robot, you can set it as speeds to move the robot either forward or reverse. The wheel is the part that makes the robot run with the power from the DC motor, and they have rubber tires. So be careful when installing the wheel onto the motor shaft. To do that, you can align the hexagon hole with the hexagon shaft. The battery case can hold 4 AA batteries that supply power to the robot. If your robot will be stored for too long, make sure that you remove the batteries from the battery case. The fiberboard mainframe is the largest fiberboards in the kit. It contains holes that are identified with numbers and letters. The fiberboard midframe contains 8 holes, and it is the next largest of the fiberboard frames in the kit. The kit also contains 3 LED boards in the colors red, amber, and green. The 3 colors are activated when the board receives electric signal. And the buzzer, when receives electric signal, it blares in warning sound, which is a little bit of an annoying. The IR sensor contains an infrared emitter and receiver. The emitter is a clear bulb and the receiver is a black one. There is a small cream-colored capacitor between them. The IR sensor detects the reflection of infrared ray from the black or white color track, which enables the robot to move freely, for instance, moving forward or backward. The push button switch is located on the circuit board. When the button is pressed, the circuit is completed or turned on, and when it is released, the circuit is open or turned off. And the wires consist of 3 conductors, black, red, and yellow. Make sure that you install them so that the black wire connects to the pin with the white triangle. The L frames are used to connect various components of the robot together, and they come in 3 different sizes based on the number of the holes, which can be 2x6, 2x2, or 2x1. The motor frame is used with the DC motor and also connects frame with the right angle. It has a built-in female screw so that there is no need to use a nut. Also, it's different from the L frames because the outer surfaces are covered with dimples in the metal. The robotics kit also contains 3 types of supports which are used to connect the frames horizontally. They can be 7, 20, or 35 millimeters long, and you can measure them using the scale on the lid of the robotics box. and you can measure them. The self-tapping screw is used to connect a wheel to the motor shaft. So just be careful when you use it so you don't over tighten it. You will also find in the kit 100 machine screws and 100 nuts to go with those machine screws, one cap nut, one Phillips screwdriver used to install the screws, and one nut driver that can be used to hold nuts when installing screws. The software used to program your Roborobo is called Logic, and this is a screenshot of what it looks like. This software only runs on PCs with Windows 7 versions and up. The software can still run on a Mac computer if you have the Windows software on a virtual machine. You can download Logic using the link which is provided in ELC. The version of Logic that has been the most stable for us is version 3.3.0.1, and the file provided for you to download is in the robotics folder on ELC. Later versions of the software are still unstable and some platforms have been avoided. To use Logic, you can apply the basic simple programming principles you learned while using code.org. You can drag and drop the buttons into the main work area to create your program, or you can delete the buttons by dragging them onto the trash bin. So you can see, you can move these onto the work area or drag them to the bin. For more detailed information on how Logic works, you can watch the Introduction to Logic's video available on ELC. The CPU board has several different parts. The CPU receives the signal through the import from the contact sensor board or IR board. The CPU sends the signal through the out port to the LED board or the buzzer board. Through the motor port, the CPU supplies power to control the DC motor. The power switch can be turned on or off to do the same to the CPU board. The power connector connects the battery case to the board, and the USB cable port is the place where you can connect your USB cable. There are specific robot pieces that connect to the CPU board. The contact sensor and the IR sensor connect to the in port. The buzzer and the LED lights connect to the out port. The battery case connects to the power connector, and the DC motor connects to the motor port. Now, a very important reminder before we move on. The black wire on the 3-pin cable should always be aligned with the white triangle on the circuit board. Otherwise, if the cable is not properly connected, it can cause robot malfunction. Now that you've been introduced to the robot pieces in the Roborobo kit, I will go ahead and explain a little bit about the exercise 4. For exercise 4, which is divided into 2 phases, assembly and programming, you are going to need the following pieces: the CPU, the battery case, the CPU board, the 3 LED lights, 2 push buttons, and 5 wires. You are going to follow the instructions for the assembly process contained in the activity posted on ELC, but it's basically connecting the red LED to the out 1, amber LED to out 2, green LED to out 3, push button 1 left to in 1, push button to in2, and you will also need the battery pack as a source of power and the USB cables. The graphic, the picture on the slide shows that we labeled one of the push buttons as left. However, there is no way to identify on the board which one is left and which one is right. We identified one as left simply for the purposes of programming, so we can program one of them as left to execute a specific command. If things do not happen as expected, for example, if your robot or if your lights, your LED lights don't execute the command that you were expected it would, make sure that you check the cable connections to see if something's wrong. Check if the alignment with the black triangle, with the black wire on the white triangle is right. Try unplugging and plugging the wires back in. Check your programming codes, check if the batteries may be failing or if there are any defective components in your robotics kit. Now, while you are going to keep the Roborobo kit for a few more activities, and you will have plenty of time to explore and assemble and program different types of robots, this is a reminder for you before you return the robotics kit to us. Make sure that you disassemble all the robot parts, check if any piece got lost, and if that happened, please communicate it to Dr. Hill so he can replace the pieces in each box. And please put the robo parts in the box as displayed in this picture as much as you can. Alright, this is the short video that I created for you. Hopefully you will watch the next video, which is the introduction to Projects. Hope you enjoyed.